Hello everyone, myself Purva Joshi, Assistant Professor at LG Institute of Engineering and Technology. Today we are going to study few more topics of sequence and series. So let's begin with the first topic, that is D'Alembert's ratio test. If series UN is a positive term series and limit n tends to infinite, un plus 1 upon un is equal to L, then for L less than 1 series converges, for L greater than 1 series diverges, and for L equals to 1 the test fails. Okay, so whenever we have a series UN which is a positive term series, and we will find this limit n tends to infinite, un plus 1 upon un, and its answer is L. So the convergence, divergence and test fails. This depends on L. So if L is less than 1 series converges, for L greater than 1 series diverges, and for L equals to 1 the test fails. Means we have to apply some another test. So the series that involves factorials or other products, that is it includes a constant raised to power n. So for example, we have 2 raised to n like this type of term, or factorial types of term like this. So whenever these types of term are present in question, so we will apply ratio test. Okay, so let's begin with the example. Test the convergence of the series 2 raised to n upon n factorial. Okay, so here un is given, that is 2 raised to n upon n factorial. So firstly we will find un plus 1. So for that, in place of n we have to write n plus 1. So you will get 2 raised to n plus 1 upon n plus 1 factorial. Okay, now we will find L, that is limit n tends to infinite, un plus 1 upon un. Okay, so limit n tends to infinite. This is un plus 1 and un substitute. Okay, now this 2 raised to n plus 1 we will write as 2 raised to n into 2. Okay, so this 2 raised to n will get cancelled. What remains is 2, and this n factorial will go to numerator. So here we have n factorial upon n plus 1 factorial. Okay, next we will write this n plus 1 factorial as n plus 1 into n factorial. Okay, so this n factorial will get cancelled. Okay, and what will remain is limit n tends to infinite 2 upon n plus 1. Now as n tends to infinite, this limit will go to 0, which is less than 1. So by ratio test we can say that the series 2 raised to n upon n factorial is convergent. Okay, one more example. Is the series n raised to n upon n factorial convergent? So here un is given, that is n raised to n upon n factorial. So firstly find un plus 1. So in place of n we have to write n plus 1. So here we have n plus 1 up raised to n plus 1 upon n plus 1 factorial. Okay, now we will write this n plus 1 raised to n plus 1 as n plus 1 raised to n into n plus 1. Okay, and this denominator we will write as n plus 1 into n factorial. Okay, so this n plus 1 will get cancelled, and what remains is this. Now we will find L, that is limit n tends to infinite, un plus 1 upon un. Okay, substitute the answer of un plus 1 and un. Now this n factorial will get cancelled. What remains is limit n tends to infinite, n plus 1 whole raised to n, and here n raised to n. Now take n common from the numerator. So here we have n raised to n, and here we have 1 plus 1 upon n whole raised to n, and upon n raised to n as it is, this to get cancelled. And we know limit n tends to infinite, 1 plus 1 upon n whole raised to n is equal to e, which is greater than 1. Okay, so by ratio test we can say that the series is divergent. Okay, now is the convergence of a series 2 raised to n upon n cube plus 1. Okay, so here un is given, that is 2 raised to n upon n cube plus 1. Firstly we will find un plus 1. So in place of n, just write down n plus 1. So we have 2 raised to n plus 1 upon n plus 1 whole cube plus 1. Now apply the limit. So limit n tends to infinite, un plus 1 upon un is equal to limit n tends to infinite. Substitute this to answer. Okay, now simplify. So you will get 2 raised to n plus 1, and this will go to numerator. So here we have n cube plus 1, and this 2 we will write in the denominator, that is 2 raised to n into n plus 1 whole cube plus 1. Okay, now we will simplify this, so you will get 2 raised to n into 2. We will also take n cube common, so here we have 1 plus 1 upon n cube. Okay, and denominator also we will take n cube common, so here we have 1 plus 1 upon n cube whole cube plus 1 upon n cube. This n cube will get cancelled, 2 raised to n will get cancelled, so what remains is 2 into 1 plus 1 upon n cube, and denominator as it is. Now apply the limit, right? So this all the terms will goes to 0, so what remains is 2, which is greater than 1. Okay, so by ratio test we can say that the series un is divergent. Okay, now next one is Raabe's test. So if un is a positive term series and limit n tends to infinite, n into un upon un plus 1 minus 1 is equal to L, then for L greater than 1 series converges, for L less than 1 series diverges, and for L is equal to 1 test fails. Okay, so whenever ratio test fails, then we will apply this Raabe's test. Okay, so we have a series un which is a positive term series. Okay, and we will find this limit n tends to infinite, n into un upon un plus 1 minus 1 equals to, suppose answer is L. Okay, so if L is greater than 1, then series is convergent. If L is less than 1, series is divergent, and for L is equal to 1 test fails. Okay, so we will whenever this ratio test fails, so we will apply Raabe's test. Right? Now example. Is the series 4 raised to n into n factorial upon 2n factorial convergent? So let's begin with the solution. Here un is given, that is 4 raised to n factorial upon 2n factorial. Firstly, we will find un plus 1. So in place of n, everywhere we have to write n plus 1. So you will get 4 raised to n plus 1 into n plus 1 factorial, n plus 1 factorial upon 2n plus 2 factorial. Right? Now we will find limit. N tends to infinite, un plus 1 upon un. Firstly, we will apply ratio test. Okay, so if this ratio test fails, then only we will apply Raabe's test. Right? So firstly, we will solve for this. So write down this un plus 1 and un. Okay, and we will just simplify this. So this 4 raised to n plus 1 we will write as 4 raised to n into 4, and this n plus 1 factorial we will write as n plus 1 into n factorial. Okay, again this n plus 1 factorial as n plus 1 into n factorial, and denominator 2n plus 2 factorial we will write as 2n plus 2, 2n plus 1 into 2n factorial. Okay, and this denominator 2n factorial will go to numerator, so here we have 2n factorial, and this term, that is 4 raised to n factorial as it is. Now this 4 raised to n will get cancelled, n factorial will get cancelled. Okay, this 2n factorial will get cancelled. So what remains is 4 into n plus 1 into n plus 1 upon 2n plus 1 into 2n plus 2. We will take this 2 common, so we have n plus 1, it will get cancelled, and this 2 also will get cancelled, so we have 2 into n plus 1 upon 2n plus 1. Right? Now take n common from the numerator and denominator and apply this limit. Okay, so this n will get cancelled, this 2 term will be 0, so what remains is 2 upon 2, that is 1. Okay, so here we have L is equal to 1. So this ratio test fails for L is equal to 1, right? So we will apply Raabe's test. Now for Raabe's test, we have to find firstly this term, that is un upon un plus 1 minus 1. Now we already have this un plus 1 upon un as 2 into n plus 1 upon 2n plus 1. Okay, so just reverse it, so you will get this 2n plus 1 upon 2 into n plus 1 minus 1. Simplify, here we have to cross multiply, so 2n plus 1 minus 2n minus 2 upon 2 into n plus 1. This 2n will get cancelled, so what remains is minus 1 upon 2 into n plus 1. Right? Now we will multiply it by n and we will apply the limit. So limit n tends to infinite, n into the answer of this term, that is minus 1 upon 2 into n plus 1. Okay, now we will take out n common from the denominator. So you will get this term. Now this n will get cancelled, and we know this limit n tends to infinite, 1 upon n is equal to 0. Okay, so finally we have limit n tends to infinite n into un upon un plus 1 minus 1 as minus 1 by 2, which is less than 1. Okay, so by Raabe's test we can say that the given series is divergent. Clear? Now, so in today's session, firstly we study ratio test, right? So here we have to find limit n tends to infinite un plus 1 upon un, and answer is L. Okay, so if L is less than 1, series is convergent. Okay, if L is greater than 1, your series is divergent, and for L is equal to 1, test fails. Okay, so if test fails, then we will apply Raabe's test. Okay, so for Raabe's test, what we have, limit n tends to infinite n into un upon un plus 1 minus 1. This is equal to L. Okay, now here L is greater than 1, the series is convergent. If L is less than 1, series is divergent, and for L is equal to 1, test fails. Right? So I hope you have understood in this session. Thank you for watching.